7. Cool. Did you guys just eat lunch and all that stuff?
Yep.
Yeah, so you So what we'd like you to do is, let's get everything all excited again. Show us some of the cool stuff that you've done, the stories about how you got there, and how you used to have another team member, but the robot ate him. Go.
Well, our robot has a modular design, meaning it's split into 3 parts: the chassis, the motor, and the brake, and they can be easily reattached and attached. They're easy, except. Yep. We also added these bottom pegs. This wasn't the first design. First, we just had 2 wheels, but then we added a back wheel to support it. And if it got too much weight in the front, it would tip. So we added 2 wheels. That didn't work because it had too much friction. So then we tried gears, and we wouldn't be able to move back and forward really good with a lot of friction. So then we came down to these pegs, which pretty much have little friction on the mat.
So are they taking both front and back, or just the front?
And
Okay, we're going to leave it for just a second. We want to get a record of this. Kind of a before it blows up and after. No.
We also built this little wall here along the bottom with 2 side hooks so that we could push the ice cream and pizza in the base, and we could also get the fish out of our way. And originally we were trying to use hooks to pick up the ice cream and pizza, but the hooks just weren't accurate enough and we would miss a lot. So we built this. And we also built this side guard here in front of the wheels because these little sticks would often get caught in the wheel and mess it up.
Looks like you got a couple of light sensors and a touch sensor and an ice cream dispenser. No? So tell us about kind of the strategy of why you came up with that design overall. What were you trying to do?
we were trying to accomplish as much missions as we can.
Without many attachments that would take off.
Pretty much we only have 1 attachment.
Okay, the rest is already on it. Okay.
Can you have your program?
Yeah, okay, so for programming, we try to create my blocks for the moves that we were going to do.
Okay.
So, and then what we started all the missions off with was a robot info my block that sets everything for all the missions, and it sets the basic power, which we have set to 50.
Okay.
And so that if you can just change the power, so once again working more consistent, you can speed it up or slow it down, whatever you want to do.
Okay.
And then there's the turn circumference, which is how many degrees it is for a full turn. And so it can calculate how far to turn.
Okay.
So you just need to type in how many degrees you want it to turn.
Okay.
And then there's the motor rotations, which is how far it moves, for how many centimeters it moves for 1 rotation. So it can also calculate, you just put in how many centimeters you want it to move.
Okay, Eric.
Okay, and so then the my blocks we created, we've created a turn my block, a move straight my block, a move straight to like tense on my block, and then we have line following, which is we have one for left and right, forward and backward. And our line follow has progressed over the years. The first year we just had a black and white line follow, which when it saw white it turned to the black, and then it saw black it turned to the white, and it was really jerky. So the next year we tried a 5-stage line follow, which has 5 stages, which is the gray in between right here, and then it'd have 1 on each side and then farther out, and based on how far off the gray it was, it turned slower more, and once it got right on the middle gray, it'd go faster, it'd go straight faster until it got off again. And then this year we have a proportional line follow, which has pretty much infinite stages, and it's constantly calculating how far off it is.
Okay. You have the.
You just can keep that.
Okay.
So you use the light sensor a lot, did you use other?
Yeah.
ultrasonic sensors?
We have the ultrasonic sensor and the push sensor also.
There's the, oh, you do have the ultrasonic sensor, it's underneath there. Okay.
Just make sure you write that right.
On the bottom of our robot is the sensors. And the unique thing about them is that we have two for going, one for going forward and one for going backwards. Next to those we have twigs on the bottom that flatten down the mat so that the vehicles don't pop wrong. And our other attachment is so that when it's moving away from the wall, it will see how far away it is from it, so it knows what to do.
The reason why we have three hooks on this is because these two are meant for the red rat, and this one is meant for the blue rat. And these two, they're not always accurate, so we try to in between. And then this one is, it turns, and then it catches the blue rat. And then we also have this one in the back for the trailer, and it goes under the trailer hook and hooks it easier, and it can move along with the wheels and stuff.
This is our bucket. We had a couple of different designs. The first one was right at the bottom. It had a lot of problems, like pieces would bounce out, it would run into the obstacles, and it was just messing up our robot. Our second one was completely flat, right over the ultrasonic, and pieces would bounce out, it was causing us trouble again. Then we came up with this one. This one it tilts a little, so that the pieces slide perfectly right into here, and can catch them easily.
So a question, this is a large, very sophisticated robot. Logan, if you were to kind of shake it and stuff, the pieces fall off, or is it pretty rugged? Okay.
It's pretty good.
Okay.
The only pieces that usually ever fall out are the back, because it's just kind of connected in there,
Okay.
just so it can have the tilt.
Okay.
So how does it work out for you guys to have only the, one attachment? Does it save you a lot of time? Do you want missions done?
It saves
Or?
us a lot of time in the base, and we still do almost everything.
Yeah.
Okay.
How did you guys come up with some of the decisions on what sensors you're going to use? You have quite a few sensors on the spot, so what was kind of the decision process with that?
Well, for the ultrasonic sensor, we basically use it most for following lines to know how long to follow the line.
Okay.
So once it gets a certain distance away from a wall or something, and we decided that because seconds wouldn't really work accurately, and like all these lines have like a wall, or this has the truck or the sink, this has a wall, this one has a wall, so they all have one thing that basically use ultrasonic on.
Okay. Push button's kind of like that when you want to stop, because we use it for the rats, the sink, the table, and distance travel.
When you designed something and you tried it and whatever happened, what did you do with that observation? Hey, it did this. What did you do with it?
We would use it to make the program better, make the robot hardware better.
Okay.
So how did you keep track of it? Did you have a process for deciding how to change it?
There should be in there's all the changes that we had made to the robot, all
Yeah.
in that list.
Okay, so you guys kind of kept a notebook?
Yeah. Very long.
Did you ever have to go back and reference it for anything?
Sometimes if like our change didn't work as well as we thought it would, then we'd have to go back to see what we did and so we could change it back.
What's this one gonna do?
we would get all those, and then we'd get the truck that they smelled in that at the time.
Okay.
How much, Tim? None? Okay. All right.
Thank you very much for
Thank
sharing
you.
everything. I have to ask the same question. It's an informal poll. Are you having fun with this?
Yeah.
Very cool. It looks like